when it hailed? Oh, that's a bummer. Did you run inside? Because that would not be good. All right, you guys, we're Core 1 webinar, week 7. Alrighty. Yes, that's good. I would run inside too, Danny. Being outside when it's hailing, not good, not good. Okay, I see all you guys' answers, and now we are recording. So, what we're going to do is go back, and we're going to solve this. Okay, now first of all, you guys, the creek is flowing at a maximum of 5,000 cubic feet per second, right? Well, if it was flowing at 0 before, then it's 5,000 times faster. So does that make sense to everybody? Okay, so it has to be less than 5,000, because if it was started at 0 and it went to 5,000, then it would be flowing 5,000 times faster. What did you pick? So that was not quite there, but that's okay because they're all guesses. So Tashana, don't even worry about it.
So it's going to be less than 5,000?
It has to be less than 5,000, yep, because if we started at 0, if it was never flowing, it was a dry creek bed.
And I said 3,000.
So you could be.
That was my first guess.
That's okay, that's good. Those are good guesses, but 3 times is, we leave that there, that's totally fine.
Aren't you just like counting from what's in between the 200 and the 5?
Close.
So 3, 4.
Yeah, you're on the right track.
2,000.
So let me just ask you guys this. Okay, think about this. If the creek was flowing at 2,500 cubic feet and then it went to 5,000, does anyone know how much faster that would be?
200 and then 5,000?
If it started at 2,500, let's say. So it started at 2,500 and then it went to 5,000, how much faster is that?
Isn't it like 300? Not 3,000, like 300. Yeah. Because it takes like, oh, this is hard.
Okay, well here, let me give you guys a question just like that, but with a small number, okay? So if the creek was at 2 and then it went to 4, how many times faster is that?
That's like 2. And then it went to 4?
Uh-huh.
2.
Good. Well,
I'm at 1,000?
Just
2.
Just 2. 2 times faster. Right? Because 2 times 2 is 4?
Yeah. Oh, that's how you do it?
Mm-hmm. Yeah, so if your creek started at 500 and went to 1,000, how many times faster is that?
8. 100. 10? No, 5. Wait, how much? I didn't hear you.
So if you start at 500 and then you go to 1,000, how many times faster is that?
25.
How many times does 500 go into 1,000? How many times does 5 go into 10?
5. I said 5.
No, 10 divided by 5, you guys.
Wait, it's 2.
2. Good,
How?
it's double.
5.
Right? Because 500 plus 500.
Okay.
Okay. So if you guys are thinking about what we're kind of doing is that we are actually dividing or figuring out what we need to do to multiply.
Can I do that?
So 2 to 4 is twice, right? 500 to 1,000 is twice. So if we look at this problem and we say, okay, we ended up at 5,000, but we started at 200, we just divide. Okay, so here's an easy way to divide this, you guys. So if I have 2,000 or 5,000 divided by 200, I can start taking zeros off. So I can take the end zeros off and then the next 0 off. So then what I really have is 50 divided by 2, which gives us 2 goes into 5 twice, right? Carry the 1. 2 goes into 10, 5. So 50 divided by 2, or if you cut 50 in half, what do we get? 25. So here is our answer. 25 times faster. Okay.
Oh my god, that was so easy.
It's okay, Janae. It's okay. That's why I put it up there. So 25 times faster. So that is quite a bit faster. So Not exactly 4,000 times faster, but definitely faster.
I could 3 times faster.
It's okay. We had high and low guesses, Janae. So we had very, like I said, so we had both. All right, guys. Any questions on that? 25 times faster. Okay. All right. So let's do a little more rain exploration, just because we had so much rain over the past 4 or 5 days. So Thursday morning, which was, we'll consider that day one of the flood. So we're going to call that day one. The creek, so we're still looking at how fast it flows. It was measured at 1,800 cubic feet per second. So it's definitely not up to the 5,000 yet, right? On day three, on Saturday morning, it was measured at 4,800. So what I want you guys to do is to kind of help me. We're going to make a table to represent this information, because you guys were making patterns from tables. So that's what we're going to do, is we're going to make a table, see what kind of pattern we see. So remember that our table looks like this. And then we usually have an X and a Y, so I'll put X and Y. Sometimes we can call those other things, but we'll call them X and Y. So help me out, you guys. Oh, you got that. You just thought it would be more, Dan? Oh, Donnell, really? Well, Donnell, you got to put down your guess, and then you would have been right. Okay, so you guys, what would I put? So based on this 2 pieces of data, day one, it's flowing at 1,800. Day three, it's flowing at 4,800. I need to fill out this table, because if I'm good at filling out these tables, then I can always make an equation and or a rule. So we have day one and day three. Day one is 1,800. Day three is 4,800. So what do you guys think I would put for my first 2 set of points? My first set, actually. What do you guys think?
You could put 18, 1,000, or 1,800.
Okay. Good. Good. And Danny wrote it down too. And Danny, you're good too. Okay, so you guys feel free, always jump in if you want, even if you're not certain, because then I can see what you're thinking. But yeah, so day one, that's like step one, right, on those shapes and stuff. So day one, we had 1,800. Okay, so here's what I'm going to do, because Dustin's all over there being all quiet. So Dustin, you can either be in the chat box if you want, or do it in your notepad. What would I put for my second point? Come on, Dustin. So maybe let me actually go over and just see if I can see you, because it's hard to see your screen over here, so hang on. No, Dustin, you didn't put anything in there. Dustin, hello, are you there? Say something in the chat if you're there. Dustin, yes, okay, good, yay. Okay, so Dustin, what would I put as my next X? Type it in the chat, how about that? What's my next X? If you give me the X, I won't ask you for the Y. What number do you think? I'm hearing it over here, and I'm hearing good answers. Good job, you guys. Come on, Dustin, give me a number. Right here. A 2. Okay, very close. Thank you for giving me a number. Very nice. Good job. But it's not actually a 2, but that was really close. Donnell, okay, good job. We're going to use a 3. So thanks, you guys. Way to go, way to go. So it says day 3, so we're actually going to jump to 3. So Dustin, you're right. Normally we do 1, 2. But on this one we do 1, 3 just because we're given day 3. Okay, so day 3, it says 4,800 cubic feet per second, so that's going to go there. So now we've made our table, so we're good. Okay, so here's a concept. Find the average rate of change. So on this one, you guys, average rate of change is just another name for slope, actually. And we've done some stuff with slope. And we can actually find the slope just from 2 points. So let's actually work this together. So actually, I'm just kind of curious, and you guys don't have to do it, because I know how much you are shy. So raise your hands, or just type a yes if you know how to do slope. If you remember how to do slope. And you don't have to remember with these points exactly, but if you can remember with the other points, that would be fine. And let me go over here. Sorry, you guys, I'm going to block the mirror for now. Okay, so yeah, raise your hand if you guys know how to do slope. Yeah? You guys know? You don't know?
I know.
You do know? Okay, good.
Well, I thought you said raise your hand if you do know.
Oh yeah, raise your hand if you do know. So Donnell, raise your hand. Good job. Alexandra, how about you? Do you know how to do slope? So you're not raising your hand. Danny or Dustin, you're good. Danny, how about you? How are you with slope? Are you not good with slope? You're oh, you're pretty sure? And then Alexandra kind of? Okay. Okay, good. All right, you guys. Well then let's just review it. And I know it's in one of your weeks too, so double check your week, but let's go ahead and review. Let's make sure. So your slope is always going to be rise over run. And remember that slope, we call it M. So it's rise over our run. And you guys were used to looking on a graph and counting up for your rise and then counting over for your run, right? Today we just did that today.
Yeah.
So another way to write this, and this is what we're going to use for this, is we're going to take the difference in our y's. So we're going to take y2 minus y1, because that's our rise. Our y's are our rise, tongue twister. And then for our run, we're going to take x2 minus x1. Now, you guys, I just have a 2 and a 1 just to differentiate which point is which. So my first point, 1 and 1800, that's my first point, so that'll be my x1 and my y1. And then my second point will be my x2 and my x2 and my y2. Okay. So the way you can do this, and this way you can get away from having to count on graphs, you can just take 2 points. So I'm going to take my y2, which is my 4800, and then I'm going to subtract from that the 1800. Okay. So that will give me my rise, the distance up. And then I'm going to do the same thing with my x's. So I'm going to take my x2 minus my x1. And just so you guys know, order doesn't matter. So I could do y1 minus y2 as long as I did x1 minus x2. Okay, so let's figure out what our average rate of change is. So if I take 4800 minus 1800, that is 3000. Okay, and if I take 3 minus 1, that gives me 2. And now I can just divide. 3,000 divided by 2 is 1,500. And I need to make sure I do my units. So my units are cubic feet per second. That's my average rate of change. So that water is changing on average 1,500 cubic feet per second each day. Okay. All right, so just another way to kind of think about slope. Any questions on average rate of change, which is just slope? Any questions? You guys are all quiet. Okay. All right, what we're going to do then is this last one. So what we're going to do is make an equation. Okay, now remember, you guys, when you make your equation, the equation is in the form y equals mx plus b. Okay, that is the equation of a line. And think about this. We just found m, right? M was 1,500. Okay, so that's our slope. That's our change over time. Okay, and we found that from making our table and then finding our slope. We need to find b. But if you think about in a graph, b is your y-intercept, but it's also your starting value. And if you look at number 3, it says if the initial rate is 200 cubic feet per second, that is our starting value. So really our equation is already made for us. So our equation is y equals 1,500x plus 200. So 200 is where we start, and then each day it raises 1,500 cubic feet per second. Or it flows at 1,500 cubic feet per second. Okay. Ta-da! Give me a note. So Dustin, you were a nope. So you guys are okay so far with how I made this equation? You guys doing good? Okay. All right, so we're gonna actually go away from this, and I'm just gonna do a quick review on something that you guys did in your most recent week. So one thing I want to say to you guys too is that make sure that if you haven't taken the unit test, unless you started the class late, or the mid-unit test, I should say, that you take it. Okay, you guys, there are only 3 weeks left in the quarter, and you have to at least get through the unit test. And we'll talk if you're, if you started late and stuff. But if you have to at least get through the unit test in order to get a grade for the quarter, and the quarter's only 3 weeks away. So all you guys, if you're behind at all and you didn't start late, because I know some of you guys did, you need to get through that. So there's actually 2 tests, because there's the mid-unit test, then there's a week of material, and then there's a week where it's just the final test. And on the final test, all you have to do is do a review and take the final test. So you guys, don't let this get away from you, because a lot of you are doing really, really great, and I just want to make sure that you continue on. But I do know, like I said, some of you guys have started late, and that's a totally different issue. You're just working as you go. So, and some of you may actually, because you're working really well, get to that unit test, and that's fine. But if you've been in the class since the start of the year, you need to get through that unit test, okay? We are now in week 7, and some of you guys are still in week 3 or 4. So you really, what you want to do is kind of make a plan to say, I'm going to get through at least 1 or 2 math assignments every day, and I know you guys can do it. Okay, definitely can do it. All right, but again, everybody else, if you started late, you're doing fine. Okay, so let's review something from last week, actually. So what I want to review are inequalities, just because that's kind of confusing for people a little bit. So I just have a couple quick problems on that, and then we'll be finished with our webinar today. So, Danny, did you just say, oh, good. That's good. You've been going through the review. So, Danny, that's really good. You actually, just so you know, you've been catching up really fast, and you're not behind because you started late. So you're totally fine. Okay. Anyway, you guys, so these inequalities, what we have to do first is write an equation to represent these solutions. Okay, and so a couple things to point out just to help you guys remember is that if you have a closed circle, so let me write this up here actually, if you have a closed circle like this, that means that you are including that number in your solution. So you're going to include it. Versus an open circle, that means you will exclude that number. Okay, so notice on this top graph, 3 has a closed circle, right? That means 3 is part of your solution, whereas on the bottom, 5 has an open circle, or -5, I should say, and so that is not part of your solution. Uh-oh. And we just lost a connection here, but that's okay. So you guys, if you are typing me a, that's strange. So if you guys type me a chat, I'll have to go back and check to see if you have any questions, just because the other computer went to something else. But anyway, so what this means, if I look at this top graph, 3 is part of my solution, but so is every single number less than 3. Notice this arrow on the end? That means that that line goes on forever. So all those numbers are solutions, including the 3. So maybe I want to know, how deep a certain lake goes below sea level. Well, maybe the lake goes up to 3 feet above, but then the lake goes down, 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 forever. Maybe it's the Mariana Trench, 30,000 feet below sea level.
We're going up when it's closed, and we're taking away when it's open. Or we're not taking away, we're going down to the negative.
Well, the only thing with the open and closed, Jay, that the closed means that you just include 3 in your answer.
Just 3.
But also all the numbers to the left of 3, those are all part of my answers too. Because, for example, think about a situation where you might use an inequality. So say you have $10. And so you can go to the store and spend up to $10 on clothes or something. Or you can't buy many clothes for $10, but maybe you're in the dollar store or something. So, but that doesn't mean you have to spend 10, right? You can spend 10, but you could also spend 9 or 8 or 7. So we can write that as an inequality. And what that means is, so if I were to write a graph of that situation, let's just say, I would say, okay, well, here's a graph, and it's not very straight, but we'll just say this is $10, right? And this is 0. So the solutions for you, you can spend $10, so we'll put a closed circle on 10, but you can also spend everything below $10 all the way to 0, and then I'd put another circle there on 0.
Okay.
And that would represent what you can spend.
And that's the include?
That means it includes, yep. Now if your mom said, Janae, you can go to the store, but you can't spend 10. You can spend less than 10.
Yeah.
You could spend $9.99 if you want to, but
Yeah.
you can't spend 10. Then you would have an open circle on the 10. Because you would not include it. Okay. So what we want to do is be able to write these as algebraic equations, inequalities. So here's how we would write this first one. So we'll always use x because the number line is horizontal, so that represents our x-axis. So in this first one, we would say, okay, well, x, we want to represent all the solutions. And the solutions on this number line are going to be less than or equal to 3. So hopefully you guys all remember these inequalities, but they are in your notes from last week. So if you guys are confused, make sure watch the lessons on that. But this says x is less than or equal. This line underneath means or equal to 3. Okay. It's just so strange that this computer has shut off. So hopefully, here, let me go over and see if you guys have any questions, type them now, and I'll go over and check it out. Let's see. Nope, can't get to come back up. All right, so let me just double check, see if you guys have any questions. So it looks like I don't see any questions at this moment. So good. Okay, I'm going to go back over. Okay, so now we have the bottom one. So on this one, to the right of -5 is highlighted with a line. So that means all the solutions that are bigger than -5. So we want to say then x has to be greater than -5 in the bottom one. But notice I don't have an equal sign under the inequality sign because I have an open circle. So -5 is not part of my answer, but everything greater than -5 is part of my answer. So -4.99, -4.98, those are all part of my answers. Okay, so your first exercise, you'll be given graphs like this if you haven't already gone in there, and then you'll have to identify the equation that goes with the graph. Good? All right, so let's go to the next one, and then I'll double check with you guys and make sure you don't have any questions. So this is our last example with just some review on inequalities because they're new. So this one I wanted to go over just because there's one little thing that I want you guys to think about when you're doing these, and that's how you solve it. Okay, so when you solve these, you solve them like you would any other equation. Okay, so when we're solving for x, we move everything away from x. We move everything to the other side. So in our first example, we add 4, okay, because we move the 4 to the other side. Okay, and then we'll just continue to write everything down, so we didn't do anything to the 3x, so that stays there. A -4 and a +4 makes 0. Okay, so that's gone. We carry down our inequality sign. 8 plus 4 is 12. Okay, and then our final step, we need to undo the 3 times x. And to undo that, we are going to divide. So we divide both sides by 3. And then we know that 3 divided by 3 is 1. Okay, so then we are left with just the 1x. So this is just like what you guys have been doing so far, no difference, right? Carry down our inequality sign, and 12 divided by 3 is 4. Okay, and that is our solution.
That's the answer?
That's the answer.
4.
X, and now really what's important in these though is you can't say the answer is 4, only because it's an inequality. So it's 4 plus all the numbers smaller than 4. So let me actually draw this out for you guys on a number line so you can see. So say I have a number line. I'm just going to do a rough one over here. Okay. What I'm going to do then is plot my number 4. So we'll just put it anywhere. I'll just say 4 is here. Okay, so it's a less than or equal to sign. So remember that anytime it's less than or equal to, I need to do a closed circle. So I'll do a closed circle on 4 because it's equal to 4. But then it says x is less than or equal. So I have to put an arrow to the left because all those numbers to the left are less than 4. So really my solution is not just 4, it's all the numbers that are less than 4 as well.
So if the sign is this way, then it's X or
Yep, well, no, that's just if it has a line underneath. Yep, if there's a line underneath, that means that you include the 4. Because the little line underneath is part of an equal sign. So in reality, you could actually write this like this. So this sign here, less than or equal to, is really the same thing as if I were to say less than or equal to like that. So those are kind of the same. Those are kind of the same thing. It's just a shortcut way of writing less than or equal to. Okay. All right, so let me just double check, you guys. If you have any questions, I'm going to go back over, see if I see. Okay. So how are you guys doing over here? Any questions on any of that? Danny, just type in.
The one with the line under is the exclude.
That means include. Include, yeah. So if you have a straight line on the bottom, that means it also equals that number. So include it. Work on it, like practice. Yeah, and you know, too, Danny, when you get to, I don't know if you've gotten, I don't think you've gotten to those yet, but when you get to the, because it's after the mid-unit test, but when you get to the inequalities, you will have a lesson that will be very clear and explain a lot of things. So it's
exclude is the
open circle.
Open.
Or it's just the greater than sign, or it's just the less than sign.
Wait, I'm trying to write notes. So is that?
Oh, that means include. Yep. Okay. So then just put a less than.
And then the other one is like.
Yep. So Donnell, I don't know what to do on the other thing for review. It was hard, I think. Okay. And so yeah, Donnell, if there's anything on the review that you have questions with, send me a message in Schoology, and I will explain it on the message, or else I can call you back and explain it that way too, or we can do a webinar together if you want to as well. So good, Danny, that's good. I cannot get into the test either. So Donnell, are you, so maybe you need to call me when we're done. Are you taking the mid-unit test? Okay, so it should say, here's how you'll know, Donnell, if you look at the test, it should say mid-unit test versus the test, because you won't be able to get into the unit test yet because you have to do a review and actually submit it. But you will be able to get into the mid-unit test, and that was back in week 5, I believe, so make sure you're in week 5, and then you'll be able to get into the mid-unit test. But yeah, the actual unit test, you will not be allowed to take that until you actually do the review and submit the review. So it won't open up until you submit the review for the actual unit test. But that unit test is actually this week. So don't take the unit test until you've taken the mid-unit test. That way I can make sure that you're doing okay and that there's no hard things in that. So yeah, so Donnell, yeah, make sure you're in week 5 and make sure you've done the right review too. Hopefully you have, but double check week 5. If you've done the unit test review, then you're probably good either way because it would have included those same items, okay? All right, you guys, so let's do our last, or I'll wait for Donnell actually typing me a note. And then we'll do our last problem here. Okay, so let's go back. All right, so our last problem, you guys, we're going to solve this just like we would any other equation. So again, we have to move everything away from the x. So we have a positive 5 here, so we want to subtract 5 and subtract 5 from the other side. Okay, and then I usually just draw a line underneath, so I separate it. 5 minus 5 is 0, and I am left with negative 2x is greater than 13 minus 5 is 8. Okay, you guys, here's a really important thing. So everybody, really quick, make sure that you pay attention to this. Okay, this is a really important note, and I'm going to write it right here next to the problem. So anytime you divide, which is what we're about to do, or multiply, and sometimes we multiply by the reciprocal, so that's why we're saying multiply. Anytime you divide or multiply by a negative number, by a negative, okay, which is what we're about to do here, about to divide by a negative 2, it's really, really important that we switch the inequality sign. Okay, so switch the sign. That's the only difference between an inequality versus an equation, is that we have to switch the sign anytime we divide or multiply by a negative. And you guys can see that if we were graphing it and we didn't switch the sign, the arrow would probably end up in the wrong place. It would go the wrong direction. So we always want to make sure that we switch the sign. So that's what we're going to do here. Oops, running low on power. All right, so what we're going to do is divide both sides by a negative 2, and as soon as you hear negative, when you say that to yourself, you should think about this star. Divide or multiply by a negative, we switch the signs. Well, I'm dividing by a negative 2, so what I want to do is first write my x, and then, oh, I need to switch my sign. So instead of a greater than sign, I'm going to have a less than sign. Okay, and then 8 divided by a negative 2 is negative 4. Okay, so I made sure to switch the sign. So if I'm doing my number line, so say I have my number line, it would make a huge difference if you didn't switch the sign, okay, because your arrow would go the wrong way. So say I have my negative 4, and I'll just put it right here. Okay, first of all, I need an open circle because it's just a less than, right? There's no line underneath for less than or equal to. And then it says x is less than negative 4, so I have to go to the left and make my arrow to the left. So just be really careful, because if I hadn't switched my sign, my arrow would go to the right and I would get the wrong answer. Okay, so that's the only trick to that. So
every one is going to be a different arrow. Like the arrows will go different.
Yep, depending on which
way.
way.
I see you did at the top.
Yeah. Yeah, so depending on which way, and again, you guys, I encourage you to, oh, Donnell, because when you divide or multiply by a negative, you end up in the other side on the number line, so you end up on the negative or the positive, depending upon which one you have. So you have to switch the sign so that you end up in the right quadrant. And I can actually show you, although I don't think you're coming tomorrow, but if we can sit down, I can actually visually show you how that works. But as long as you think to yourself, okay, if you divide or multiply, okay, good, yeah. If you divide or multiply by a negative, just always remember in your brain, switch the sign, that way you'll know to switch the sign. Okay, so is everybody doing okay? Alexandra, I haven't heard too much from you, or Dustin, but are you guys all doing okay with everything? Any other questions about anything? No? You guys are good over here? Is awake back there?
Yeah,
Okay, I can't see you because I'm facing this way, which now that's not even there, so I could actually face this way. All right, you guys. Well, good. So just make sure, like I said, the biggest thing, you guys are all doing really well. The biggest thing is just staying caught up. So don't always wait for me to get you guys caught up. Make sure that you're trying each day to, get a couple things done, kind of get through it. At the start of the week, look at what's in that week. I mean, if you can get caught up, like I said, this week there's no assignments. There's just a review and the test. But some of you guys haven't taken the mid-unit exam, which you need to do that first and then do one more week. So just now is the time, you guys. Now is the time to buckle down, just because there is only 3 weeks remaining.
For second quarter?
First quarter.
Oh, I thought this was already first quarter.
This is first quarter. It's just not over yet. So.
Yeah. Wait, it's over in 3 weeks.
Yeah.
I said that. I said for like second quarter.
Yeah. So you're just in first quarter still, but first quarter's almost over. So all right. So let's make sure. Okay, you guys. So if there are no questions, then that concludes our webinar for this week. But let me know. You guys definitely am accessible. So send me a note, a message, whatever you need to, if you need any help or if you're concerned. But I know you guys can do it. So we'll see you all later.
Bye. Bye.